Hi and welcome. I'm trying to learn biology, today thermoregulation, and after we've done it, we're gonna do neckstretching. And if you participate in the neckstretching, that is at your own risk. In the last part we did proteins, so let's get shortly about the key points of proteins. If people have too little protein, it is called kwashiorkor. And the amino acids which can be attained only through eating are called the essential amino acids. Proteins from meat and fish are called first-class proteins because they contain all the essential amino acids. And from plants they are called second-class proteins. And proteins cannot be stored in the human body. Who's the drilling? Proteins cannot be stored in the body. Okay, and thermoregulation. I think that is the second part of thermoregulation. So let's go shortly over what we had here. Thermoregulation is controlled through homeostasis. Yes, it is. But it was very but now the body temperature should be at 37 degrees Celsius. If it is too low, it is called hypothermia, too high hyperthermia. And if it is too high, people can get a heat stroke, and also it oftentimes occurs at the same time that they're getting dehydrated. And various things are done to keep the body temperature at 37 degrees. And if someone is too hot, when one way to regulate it is to sweat, and when I don't know what it's all called, it's not written here. Water comes out, the water is on the skin, and basically sweat is there, and that sweat evaporates, and that cools. I want to think about a little thing. And if the water evaporates, it does cool then. Sweat is also sweating, and also more blood is sent more to the outside of the body, more to the limbs and extremities, more to the fingers, and the skin gets more red, more blood is coming to the capillaries, more to the outside. And if it's too low, then, for example, shivering is done, and with other muscles contracting, and with also vaporizing. This increases the rate of respiration, and more energy is released as heat. Rate of respiration, with respiration we mean breathing. Not respiration, but the sense of breathing. I don't know if it's true. Yes, it could be that shivering causes increased respiration need. And it makes sense if most of the muscles are contracting. And also another idea is to send less blood out, so the opposite to hypothermia, send less blood out, and the skin gets more blue, starting with the nails and the fingers, the lips. And also to sweat less, so basically all the opposite. Okay. It is important to keep the body temperature at 37 degrees because it is the best temperature for enzymes in the body to work. Or that is basically the only right one. All the others are wrong. 37 degrees. And that is the temperature at which enzymes in the body work. Okay, that's kind of work out the best. Enzymes control the rate of chemical reactions in the body and so are important molecules. Let's read that sentence again. Enzymes control the rate of chemical reactions. So how often the chemical reactions happen in the body, and so are important molecules. What is with important molecules? Enzymes control the rate of chemical reactions in the... I don't understand the sense. I don't know what the molecules are doing. Enzymes control the rate of chemical reactions in the body, and so are important molecules. So we're saying important molecules are controlling the rate of chemical reaction in the body. That is what I want to say. Enzymes and molecules are controlling the rate of chemical reactions. I'm a bit wondering if I really try to understand these things. I don't just want to tell what is written here. No, and basically I want to tell it with my own words. And now if I turn it now around, can I say now enzymes are controlling it? Like as if they would be in charge. And I think that is not meant with it. It is more meant like whatever, the other thing. It is just the properties of the enzymes which have then the outcome of having a specific rate. But it's not that the enzymes are in charge of making that. But it's rather the homeostasis. We had here homeostasis, negative feedback, the receptors are recepting, the human body processes, and the effectors are released. Well, the nova is in charge. It's just a bit of processing and then the releasing of the effectors. Okay, we take with a bit of, we are again getting a little stuck over basically nothing. Are the enzymes controlling the rate of chemical reactions? They are not in charge of it. It doesn't really make sense. Let's just read on. Any change in body temperature is detected by the thermoregulatory center in the brain. So in the brain there's the thermoregulatory center. And this will bring about these correction mechanisms. Now if the body is too high, with its temperature too low, then the thermoregulatory center in the brain does bring correction mechanisms into effect. Sweating, drawing blood in, or the opposite, shivering, and sweating less, and blood to inside. The body temperature is detected in the thermoregulatory center in the brain. Now, if we don't just want to repeat that, but we want to understand it, we have to ask a question. Is the brain detecting it, or are the receptors in the body detecting a change? Body temperature is detected in the thermoregulatory center in the brain. It is processed. These changes are then processed in the body. I think that is done in the thermoregulatory system in the brain, thermoregulatory center. And there is not a body temperature detected, there is the negative feedback detected that it is not as high as it should be, or too high as it should be. Detected is it through the receptors, and then is it processed. Now in a way both processes can be called detected, and already in part 2 they are messing it up and interchanging these both names of receptors and processes and detection. So do we making the mistake of just messing it up and declaring recepting is the same as detecting, and logically processing something and thereby detecting what the difference is, and we made the difference because we tried to understand it and not just to repeat it? Or are we already breaking with what we said? This means that receptors in the body detect a change in the body. The receptors are recepting it. Recepting something, that means detecting it. Detecting in the sense of sensing it. These changes are then processed in the body. Erst here are they understood. They are processed. Now in a way, though, the body temperature is then detected by the thermoregulatory center in the brain. In a way, I know the answer. The nerves are measuring it in the body, and the human brain now looks better in the way that can be called detected. And if the temperature, they don't want to explain that, not in the least. They just want to say if the temperature rises, sweating happens and bring the blood to the outside, and if the temperature falls, blood is drawn in and shivering is done. That's all. They don't want to talk about anything. Now, if the thermoregulatory center detects it, then the temperature is too high, changes occur. If it is too low, if the temperature drops, changes occur to slow down the heat loss. Now, if vasodilation happens, I basically for these two words, I saw these two words and I wanted to go to these two words. The increased sweat production is started if the temperature is too high, and that leads to evaporation and widening of blood vessels, and blood flow near to the skin surface, and that is called vasodilation. And if the body temperature is too low, then decreased sweat production and closing down of blood vessels close to the skin, vasoconstriction. Now that, not as they say it, but that is the desired outcome, is that the body temperature is restored to its normal parameter. Other people who have the wrong parameter, Now, this here presumes that it turns to normal. That's of course not happening if it is way too cold and the purple is, and the person is getting purple and freezes to death when that is not restored to normal, or if a person is in the heat, or the moisture in the air is too high when the person cannot sweat and the person dies. Now, a part of that big, just not mentioning of that big difference, are the people who have in the brain basically the wrong desired number written. Now, here's written as an example. It works like a thermostat. The receptor is recepting what has changed in the temperature, and then the processor compares the stimulus with a set point like the thermostat, like the temperature on the thermostat dial. Other people who have a wrong set point. That would be interesting. And if other people who do not have just always the wrong set point, but just from time to time. Set point, that sounds so fixed, and also 37, but it can change with fever. Who is setting the set point now to fever? Who's in charge of that? Because it sounds a bit like negative feedback, nothing is done. If not a change to what is written in the register for the written under body temperature 37, who is now going there and saying fever 38, 39? Are the people who have a wrong number, who have written 35 or 39 permanently? Are the things which can have an influence on that? The temperature is not the same in the morning as in the evening. What has an influence on that set number? And again, it becomes obvious that we have completely different questions, as if I told you, when people start to sweat if they're too hot and to shiver when they're too cold. No, it is not their fault. We will continue in the next part with something new to biology, but we're going to go then back to his two words here. And then we're going to learn them. Vasodilation, vasoconstriction. They're pretty easy. Vasodilation, vasoconstriction. There we have it also. Vasodilation means widening. Now we're having also medicine and in another series, and we're having also interventional cardiology and another things, and where the word dilation is important. Vasodilation seems to widen, and vasoconstriction logically means to close. In the next part, we will have water biology. Here we will do the neck stretching. If you're here for biology, you can go directly to the next part with something else for thermoregulation, probably, but we will come back at the beginning to these two terms, vasodilation and vasoconstriction. And I think we're going to do a little presentation about it. We're just going to say what vasodilation and vasoconstriction is. Now, if you're here for that, go directly to the next video. We're going to do the neck stretching in 2 minutes. If you participate, that is at your risk. And I would now hope we start. And let's start with that one. Yeah, lifting the arms up. And we're stretching with the fingertips high up. And stretch to the outside. And again down. Again, stretch to the outside. Stretch out the fingertips. And down. And now we're doing stretch high in front of the fingers. High up. And back. Not just to the side, but back with the fingertips. And down. And to the front. Higher up. Now we are doing the police officer, one more shower. So that is stretching, but not to cause anything. Lift the arms up and open them to the side. Again in the arms up. And open to the other side. Begin down. And down. And yes, having the feet shoulder width apart, we're breathing in, tall up. And breathe out, bring the head to one side. Breathe again in. And out, turn the head to the other side. Breathe again in. And out again to the first side. And make a half circle down over to the other side. Breathe again in. Breathe half out. And then make a circle again back. We're doing the clap in the morning, breathe in, arms up, throw the arms back, draw shoulder blades together, again in and up, and out the arms down, shoulder blades together, and up. Cross the feet and breathe out and lean back, the feet into the wind, breathe in and up, and out we're going over to one side, Releasing it into the middle. And out of the other side. Again in. And out the arms down. Now turn left. We're ending with eagle's wings. We're breathing in, lifting arms up. And out. And the last time in the arms up. Close your hands and bring them down. Now this was the very short neck stretching. I thank you very much and next time.